To demonstrate how to go about constructing confidence intervals around a sample mean, what I have here are data for 18 men in terms of their body temperature in degrees Fahrenheit. The first thing we'll do is find the values for the various sample statistics we need in order to compute the confidence interval. So let's first of all, using the count function, find the number of cases we have data for, and that's 18. Let's also find the sample mean, which is going to be 96.18 degrees, and also the standard deviation. And what we're going to do is use the sample version of the standard deviation formula, obviously. And we see a standard deviation of about 0.832 degrees Fahrenheit. Now to construct the confidence interval, let's go ahead and find the standard error. The standard error is going to be nothing more than the standard deviation divided by the square root of the sample size. And our standard error here is 0.196. The confidence level, let's go ahead and use a standard 95% confidence level. The probability value for alpha, or the p-value, or the alpha level we're using here, is going to be 1 minus the confidence level divided by 100. And keep in mind, we divide the confidence level by 100 to get it into proportion. So 1 minus 0.95. So 95% of the area under a curve is contained within this interval, which means 5% is not, or 0.05 proportion is not contained in this interval. The degrees of freedom is going to be merely our sample size minus 1 for this one sample mean, so 17 degrees of freedom. And to find the critical values, we're going to use the t.inverse.2t function in Excel. The 2t indicates it's two tails. So we don't need to divide our probability value by 2. So we identify what the probability value is, somewhere between 0 and 1, comma, and also then the degrees of freedom. And we see the critical values are plus and minus 2.110. So the margin of error is going to be simply the t critical values times the standard error. And there we have a margin of error of plus and minus 0.414 degrees Fahrenheit. Now what I'm going to do is copy the mean down here. We don't need to, but I like to keep the mean as right next to the lower and upper limits of the confidence interval. So the lower limit is going to be the mean minus the margin of error, and the upper limit is going to be equal to the mean plus the margin of error. And so we see then the 95% level, the confidence interval around the sample mean of 98.18 is 97.77 up to 98.60. Now we can also then go in and change the confidence level if we so choose to 90% confidence level or 99% confidence level. Those are the standard ones. I'll go back to 95% for our example right here. So this is a fairly flexible spreadsheet for finding different confidence intervals regardless of the confidence level we're using. Now one last function in Excel that I want to show you that can be used for constructing confidence intervals around sample means is the confidence.t function. And let me just demonstrate how to use that. Equal, and as the name implies, confidence.t, open parenthesis. Now we identify the alpha level between 0 and 1, comma, the standard deviation for our variable, and the sample size. Now what it will do, it will automatically calculate the appropriate degrees of freedom. It will also then identify for that degrees of freedom and the identified probability value the appropriate critical values of t, and then it will compute the margin of error. So it cuts off a little bit of the work that we've had so far, but not an awful lot. But some may find then that we can avoid then identifying the degrees of freedom and the t critical values and just go right from the probability value right to the margin of error. To demonstrate how we can use Excel for computing confidence intervals around the difference between two sample means, I've got data here for both 18 men and 18 women in terms of their body temperature in degrees Fahrenheit. The first thing we'll do is find sample statistics for each of these groups. So we'll find then, using the count function, the number of cases we have here for under the men category. And we'll do the same thing using the count function for the number of women, and they're 18 in each, which we could easily see there. Now let's find the average for both groups. So using the average function, we see the mean is 98.18 degrees Fahrenheit for men, and the average body temperature for women in this study is 98.32 degrees Fahrenheit, so slightly warmer temperatures on average for women than for men. Now, to find the standard deviation for each group, I'll use the sample formula or function in Excel for the standard deviation. And we can see here the variation for men is a little larger than it is for women, although women on average have higher temperatures. To find the standard error then for constructing our confidence interval, what we're going to do is, first of all, I will take, and I'll put this in parentheses, we will take an H6, in cell H6 is the standard deviation for men, and we're going to square the standard deviation for men and then divide that by the sample size for men. We will add to that then the standard deviation squared for women, which is the variance, and divide that by the sample size for women. Now, the reason why I put this formula into parentheses is that we have to take the square root of this. So we then see that the standard error for these two samples, for comparing the two sample means, is 0.236. Let's use a 95% confidence interval for first example here. And the probability value then is going to be 1 minus that confidence level. Whoops. 1 minus that confidence level. Of course, we have to divide it by 2. I'm sorry, by 100, I should say. Got ahead of myself there. And there we have 0.05 for our probability or value, or the alpha value. Now, to find the degrees of freedom, it's the two sample sizes added together, sample size for the first sample plus the sample size for women, and we subtract 2 from that sum. Now we have the information we need to find the critical values of t that we will use for constructing this confidence interval. So what we'll do is use the t.inverse.two-tail function, and two-tail because half of our confidence interval goes above the mean difference and half goes below the difference between means. And now what we do is we will go up and find the probability value of 0.05, comma, and the degrees of freedom, which is 34 in close parentheses. So our critical values for this confidence interval are plus and minus 2.032 for this comparison. Now for the margin of error, we'll take the critical values and multiply that by, or those by, the standard error. of 0.480. And now we have the information we need for constructing the confidence interval around the difference between these two sample means. To find the difference, we'll take the mean from the men, subtract from that the mean for the women, and women on average have temperatures that are 0.14 degrees Fahrenheit warmer than men. What we'll next do is take then to find the lower limit, the difference between the two sample means, and we subtract from that then the margin of error. Then the upper limit is going to be, again, the difference between the two sample means, and this time we add the margin of error. And so our confidence interval ranges from minus 0.62 up to 0.34. And since 0 is contained within this interval, the difference between these two samples then is not statistically significant. At the 95% confidence level, the populations from which these two samples were drawn may have differences in average temperature, where men have average temperatures that are 0.62 degrees lower than do women, or up to 0.34 degrees higher than do women. So it's possible then, that very likely, that these samples came from populations where there is no difference in average mean temperature.